guys, welcome to 6.3. Today we are discussing properties of all of these wonderful trig functions. So we'll talk about domain and range of sine and cosine. We'll find all 6 trig values given one function and a sine of another, and then we'll talk about even and odd properties to evaluate. So these are the 6 trig functions and their symbols. Here is a list of all their domains, and here is a list of all their ranges. This won't come into play too much until we start graphing. So I'm kind of not really going to look at this quite yet. Okay, so periodic properties. Sine values repeat every 2 pi. Actually, sine and cosine and secant and cosecant. So every full circle, they repeat. Okay? Tangent and cotangents repeat every half turn, so every pi. Okay, and that might help us with these. So when you have some angle that you can't actually visualize on the unit circle, here is a trick. If it's sine or cosine or secant or cosecant, you could keep subtracting 2 pi and then see where it would really land. Okay, so I'll show you a couple ways to do this one. So if you were to subtract 2 pi, subtracting 2 pi as a common denominator of 4 would be like subtracting 8 pi over 4. Okay, so what's 17 pi over 4 minus 8 pi over 4? Well, that's 9 pi over 4. That is still too big for the unit circle, so I'm going to subtract 2 pi or 8 pi over 4 again. And now 9 pi over 4 minus 8 pi over 4 is 1 pi over 4. So really, sine of 17 pi over 4 is going to have the same value as sine of pi over 4. Because it cycled the unit circle twice and then it landed on pi over 4. So now all we have to do is find sine of pi over 4. And that is on the circle. Sine of pi over 4 we know is root 2 over 2. Okay, so that's one way to do that. To be honest with you, here's another way. Just keep counting by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. No, I'm counting wrong. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pi over 4 would be here at pi over 4. So there's another way to do it. Okay, that was really annoying probably. Okay, letter B, cosine of 5 pi. Again, it's past 1 cycle of the unit circle. So why don't we subtract 2 pi, and then we're at 3 pi, still too big for the unit circle. So let's subtract 2 pi again, and now we're at cosine of 1 pi. And that is on the unit circle, and cosine at pi is negative 1, because that would be right here. All right, and then letter C, tangent of 5 pi over 4. Now, tangent repeats every pi. So we don't want to subtract 2 pi, we want to subtract 1 pi. But as a common denominator of 4, pi is just 4 pi over 4. Okay, and if you subtract those, you get pi over 4. So tangent of 5 pi over 4 is the same thing as tangent of 1 pi over 4, and we know at pi over 4, tangent is 1. Because since sine and cosine are the same and you divide them, you get 1. Okay, so some tricks when the numbers get bigger than 2 pi. Okay, and then here are all the signs of all 6 trig ratios. In the first quadrant, they are all positive. In the second quadrant, only sine and its reciprocal are positive. In the third quadrant, only tan and its reciprocal are positive. And in the fourth quadrant, only cosine and its reciprocal are positive. Now, some people remember this by saying all students take calculus. It's just a way to know which trig functions are positive where. Okay, so that's kind of helpful. And then these are all of the identities. I believe you guys should know these by now, right? Cosecant and sine are reciprocals. Secant and cosine are reciprocals. Tangent and cotangent are reciprocals. I think we know those. I believe we talked about that tan is just sine divided by cosine. Therefore, the reciprocal function of cotangent will just be cosine divided by sine. It's just the reciprocal of this one. And then these are just repeats of these, so we don't have to worry about that. Now, these you guys might not know. These are called the Pythagorean identities. Sine squared plus cosine squared is 1. Tan squared plus 1 equals secant squared, and cotangent squared plus 1 is cosecant squared. And I have some tricks about those that we can talk about in class that I don't want to put on video. And then even and odd properties. Sine of negative theta becomes negative sine theta. Same with cosecant. But for cosine, if you're cosining a negative theta, it's the same as the positive cosine theta. And then tan and cotangent of negative theta actually equal negative tan of theta. So these four, their negative angles just equal the negative version of the function, but cosine is the positive version. Okay, so on the back side, I think we're going to use some of those identities. So keep this page handy for the back. All right, now all the fun examples. So number one, if I give you guys two trig functions, values, can you find the remaining four values? So a couple ways to do this. I always like to draw a picture for these just to see what's going on. So first of all, if sine and cosine are both positive, we must have a triangle in the first quadrant. Trig is all about triangles, so let's get in the habit of drawing these out. So we know sine, oh here's theta, theta is always coming from the origin. We know that sine is opposite over hypotenuse. Okay, so let's make the opposite root 5 and the hypotenuse 5. And we know that cosine is a over h, adjacent over hypotenuse, so that means that this must be 2 root 5. Awesome. If you ever need to, you could do Pythagorean theorem to get a missing side, but we were able to just use them from the given. Okay, we want you to make a list of all the remaining four. So we got sine, we got cosine. Let's do tan. So tan we know is going to be opposite over adjacent. So root 5 over 2 root 5, but that reduces to 1/2. Okay, and then we need cotangent. Well, cotangent is just the reciprocal of tangent, so that's easy too. And then secant and cosecant. So secant is the reciprocal of cosine, so that's 5 over 2 root 5. Now if we rationalize it by root 5, that's going to be 5 root 5 over 10, which is root 5 over 2. And then cosecant is the reciprocal of sine, so that's 5 over root 5, but if we rationalize it, it's 5 root 5 over 5, which is just root 5. And we can talk about rationalizing in class if you guys don't know how to do that. Okay, so not too bad on those. Okay, let's use some more identities. No calculator. Evaluate these functions. So here's the good news. When you see common angles, there's probably a way to use an identity to simplify. So I'm going to pull out our identity sheet here. And let's see if we can apply any of these. So I would start here. What's sine over cosine of a common angle? So sine over cosine is tan of that angle. So really, all this business is really just tan of 20. And then, oh my gosh, we don't even need to do anything. What's tan 20 minus tan 20? It's just 0. So this is just 0. Okay, so same thing on B. What's another way to write 1 over secant of something? So we probably have that somewhere. Well, not really. If 1 over cosine is secant, then 1 over secant is cosine. I hope you guys are okay with that. Also, something I should point out, all of these also work for higher powers. So like if it's squared, you could do it with squared. Okay, so just a heads up, it works for squared too. So 1 over secant squared of an angle is actually the same as cosine squared of that angle. Right? Because secant and cosine are reciprocal functions. And then what's sine squared plus cosine squared of a common angle? Sine squared of an angle plus cosine squared of the same angle equals 1, regardless of the angle. So these problems are always going to come out nice when you're using the identities. Okay, this one is actually very similar to the first one we did up here. I would say draw a triangle again. Okay, now let's be careful. What quadrant are we in? Where is sine positive, but at the same time cosine is negative? It's not in the first. Where else is sine positive, but cosine's not? It's in the second. So we're drawing our triangle in the second quadrant. Okay, so sine is O over H. So opposite is 1, hypotenuse is 3. This time we will do Pythagorean theorem to get the third side. So a squared plus b squared equals c squared. So what is that? 9 minus 1 is 8. So root 8, but simplified root 8 is 2 root 2. So we're going to leave it like that. Okay, let's find the remaining 5 trig functions. And it's super easy if you have a graph. So cosine is a over h, so 2 root 2 over 3. Secant is the reciprocal of cosine, so 3 over 2 root 2. But if you rationalize it, root 2, you get 3 root 2 over 4. Okay, we didn't do cosecant. We might as well do that one. That's the reciprocal of sine, so that would just be 3 over 1, or 3. And then tangent and cotangent. Tan is going to be O over A, so 1 over 2 root 2. But if you rationalize it, root 2 over root 2, you get root 2 over 4. And then cotangent is just the reciprocal of tangent. So I'm just going to take the reciprocal of this original one, and it's just going to be 2 root 2. All right, so that's finding all 6. And then lastly, even and odds are actually pretty easy. I'm going to pull out my even odd properties here. So cosecant of a negative angle is equal to the same value as negative cosecant as if the angle was positive. Okay, so cosecant of 30 on the unit circle, we know sine of 30 is 1/2, so cosecant of 30 would be 2, so this would just be -2. And these would be no calculator also. Okay, now cosine of a negative angle is equal to the positive cosine of the positive angle. They have the same value. And we know from the unit circle that cosine of pi over 4 is just root 2 over 2. So that's it. All right, guys, we are done. Thank you for watching 6.3. Please subscribe.